In this video, we are going to see what happens in a power system during a lightning strike. In other words, we are going to see about over voltage transients. First of all, let us see what you mean by a lightning strike. So in most of the buildings, we might have seen a lightning rod like this or a lightning arrestor. So what is the purpose of this? To protect the building from lightning. So why you need to protect the building from lightning? Because it is an electrical discharge that takes place between the atmosphere and the ground. So normally it can reach the top of a building or a tree or anything whichever is at the top. So we keep this at the top to protect the building from lightning. Lightning strikes instantly generate high energy and large surge current flows. If you take a charged cloud, the separation of charges create a strong electric field, and if it is strong enough, it will break the insulating property of the air and electrical discharge takes place, which is followed by a huge sound called the thunder. What is the effect of lightning strike? It can have a direct impact as well as indirect impact. If you see the direct impact, if it directly falls on a person, you may get burned or it may lead to death also. And if it falls on a power line, there are several issues which takes place with voltage surges, flashovers, equipment damage or power outages can occur. I think when it falls on the ground, it may increase the ground potential. So in such cases, the equipment connected to it may get affected. And if it falls on the overhead line, it increases an over voltage. What is this over voltage? So over voltage means an increase in the RMS voltage. If you see this waveform, if this is the nominal voltage, for example, it is 230 volts. Suppose I am getting 260 volts, then I call it as a over voltage. But there is commonly another term is used to represent over voltage, which is called voltage swell. So is voltage swell and over voltage are same? No. So actually voltage sag and swell are common terms used. Voltage sag represents the decrease in voltage and voltage swell represents increase in voltage. Now what is the difference between this voltage swell and over voltage? Both represent increase in RMS voltage. Voltage swell is a short duration variation. That is, if the voltage increases only for less than a 1 minute, we call it as a voltage swell, whereas over voltage exists for a longer time, greater than 1 minute. So if you see here, this duration of the increase in voltage is going to tell you whether it is a voltage swell or over voltage. Now let us see this definition for voltage swell and over voltage. Voltage swell means it is an event in which the RMS voltage increases between 1.1 and 1.8 per unit at power frequency. So the important thing is the duration should be less than 60 seconds, that is 1 minute. Whereas in over voltage, it is also increase in RMS voltage, but the magnitude is between 1.1 and 1.2 per unit, but it can be for a period greater than 60 seconds. So voltage swell should be a short duration, higher voltage magnitude will be allowed. For a longer duration, the magnitude is less. Next, we will see what is this transient over voltage. That word transient means short time or short period. So transients are disturbances that occur only for a very short duration. So if you see in this sine waveform or power supply waveform, there will be small spikes here, which we call it as transients. So this is where this occurs only for a very short period. So these are called transient over voltages. In general, we can say the response of an electrical network to a sudden change in network condition, we call it as a transient over voltage. So it can be because of a lightning strike or any switching operation. Because in power system, we normally switch on something and switch off something or due to any fault it gets turned off automatically. So all these operations are going to create a transient over voltage, and any fault can create a transient over voltage. There are two types of transient. One is the impulsive transient. As the name says, impulse occurs here, but the thing to be noted here is it is unidirectional in nature. That it means that it can occur either in a positive cycle or in a negative cycle, but it cannot occur on both the cycles. Okay, so here it occurs on the positive cycle, so it is unidirectional in nature. The second one is oscillatory transient. As the name says, it is oscillatory in nature. That transient is oscillatory in nature. It can occur in both directions. So it is a bidirectional one. Let us see about impulsive transient in detail. It mainly occurs because of lightning. So we know lightning strikes instantly generate high energy. If you see this graph, will be know the current is in kiloamps. So it rises to the kiloamps in a short period and it decays after that. So this is in microseconds. Okay. So it rises in a very short period and it drops. So impulsive transient means it is any sudden non-power frequency changes in the voltage or a current waveform that are unidirectional in polarity. So you can see here it is negative in polarity in this waveform. So impulsive transients are characterized by the rise time as well as the decay time. Next we will see about oscillatory transient. You see here a capacitor is connected to the power line, and if you are connecting another capacitor to the line, you get some oscillatory transients in the waveform. So which we call it as oscillatory transient. So it goes up and down, up and down. So this is oscillatory in nature. So the best example is back-to-back capacitor switching can cause oscillatory transient. So oscillator transients will be bidirectional in nature. So this is a transient waveform caused by energizing a capacitor back. Oscillator transients are characterized by its spectral content, that is the frequency of this one. So according to this, you can classify the frequency as high frequency, low frequency or medium frequency depending upon the oscillations. Then duration and magnitude. Now we will see the sources of this over voltage. The first thing is lightning, then switching operation either due to opening or closing of some circuit, and then another thing is ferroresonance condition. So we will see one by one. So over voltages due to lightning already we have seen. So over voltage due to switching operation because of capacitor plays a major role in causing the power quality problem, because we use lot of capacitors everywhere, and normally we use for reactive power support or power factor correction, for everything we use lot of capacitors. So due to the switching of these capacitors, lot of transients will be created. Then switching of circuit breakers, then switching of distribution feeders, all these can cause over voltage. So here you can see that a capacitor is switched to the utility line, and every time when capacitor banks are switched, voltage transient of 1.3 to 1.4 per unit can be created. So you can see here, due to the capacitor switching, we are getting these type of transients. We all know about resonance condition, where the inductive reactance is equal to the capacitive reactance and the current will be limited only by the resistance of the circuit. So this is ferroresonance, which is also called a non-linear resonance. It is called non-linear resonance because when the non-linear inductance interact with the system capacitance, we get this ferroresonance. For example, if you take a transformer, the transformer core is non-linear in nature, but it is inductive. So this transformer core, when it interacts with some capacitor in the system, it creates some resonance condition, which we call it as a ferroresonance. It is an undesirable event in a power system and it has to be avoided at all cost. So this generates over voltage and over current, audible noise, overheating and flickering. And if you see the waveform, it will not be a sinusoidal waveform, rather an unpredictable waveform you will get. So this at all costs should be avoided. Next we will see mitigation of transient over voltage. How to avoid this transient over voltage. First, using lightning arresters that we know, because lightning rods or lightning arresters will be used to divert the excess energy to the ground in case of lightning. Shielding is common in transmission lines and substation. It helps to direct the lightning strokes to ground wire instead of phase wires. In transmission towers, this shielding angle, you can see here some theta is there. This can act as a protection zone to protect the phase wire from lightning strokes. Then we can have a surge arresters which are used to divert the high surge current to the ground during fault or switching operation. So for different voltage levels, we will have different type of surge arresters. Transient over voltage suppressors are semiconductor devices, actually like a Zener diode, which can give you protection in one direction or both direction. So here you can see that the power source is connected to a sensor load through this low pass filter. So using surge arresters or lightning arresters, we can divert the surge current to the ground. You can also use transient voltage suppressors, and low pass filter can also be used to filter out the high frequency transients. You can also use isolation transformers in some conditions. So let us recall what we have seen. The response of an electrical network to a sudden change in the network condition can be due to a lightning stroke or a switching operation or a fault. So how to mitigate this? You can use lightning arrestor, surge arrestor, transient over voltage suppressors, low pass filter or isolation transformer. So there are various methods to mitigate it. So if you like the video, do subscribe to Read Electric Vehicle channel. Thank you.